Imagine boarding a flight in London and arriving in New York just 3 hours later. The world beneath you blurs at twice the speed of sound, windows shimmering with the glow of Mach 2 heat, champagne fizzing beside your seat, and the horizon bending as you chase the sunset faster than time itself. This wasn't science fiction. It was the Concorde, the supersonic dream that turned luxury into lightning speed. But how did it actually work? How did engineers in the 1960s pull off something we still haven't matched today? Today, we're going deep into the heart, wings, and mind of the world's fastest passenger jet. From the nose that bowed like a bird, to engines that breathed fire, this is how the Concorde worked, and why no plane since has ever dared to fly like her again. 1. The birth of a supersonic dream. It all began with a race, not between countries for space, but for speed in the skies. The 1950s and 60s were an era of technological obsession. Jet engines had already shrunk the world, but engineers in Britain and France wanted more, to build a passenger jet that could fly beyond sound. When the British Aircraft Corporation and France's Aerospatial shook hands in 1962, they weren't just signing a deal. They were declaring war on physics itself. The goal, a plane that could cruise at Mach 2.04, more than twice the speed of sound, and carry over 100 passengers in comfort. But at those speeds, air behaves differently. Temperatures soar, metal expands, and drag becomes a deadly enemy. The project demanded technologies that didn't even exist yet. And yet, through relentless innovation and national pride, the Concorde was born, not as a machine, but as a symbol of human ambition. 2. The aerodynamic challenge. Supersonic flight is a nightmare for aerodynamics. At speeds above Mach 1, shock waves form around the aircraft, invisible walls of compressed air that can tear wings apart if not handled precisely. Concorde's engineers solved this through elegant genius. Instead of large, straight wings, they designed a delta wing, a sleek, triangular shape inspired by fighter jets. This wing allowed Concorde to remain stable even as it sliced through shock waves. But there was a trade-off: delta wings produce poor lift at low speeds. That meant Concorde needed to take off and land at dangerously high angles, forcing pilots to rely on raw engine power. To compensate, they gave the aircraft a drooping nose, which could tilt downward by 12.5 degrees during takeoff and landing, giving pilots a clear view of the runway. In flight, the nose raised back up, forming that iconic needle-like profile. The result was not just a functional airplane, it was a flying sculpture, shaped perfectly for the skies it conquered. 3. The power of Olympus, engines that breathed fire. At the heart of Concorde were 4 Rolls-Royce Snecma Olympus 593 turbojet engines, the same basic design used in military bombers. But these were no ordinary engines. They were afterburning turbojets, capable of unleashing over 38,000 pounds of thrust each. When Concorde took off, the engines roared like thunder, leaving twin trails of fire in the sky. The afterburners injected fuel directly into the exhaust, igniting it for a massive boost in thrust, essential to breaking the sound barrier. Once cruising, the afterburners were switched off, and Concorde flew efficiently at Mach 2. The heat outside reached over 127 degrees Celsius (260 degrees Fahrenheit), enough to make the fuselage expand by up to 10 inches. Engineers had to design flexible joints and expansion gaps just to handle the stress. Every inch of Concorde was optimized for one purpose: speed. Even the air intakes were smart, they adjusted automatically to slow supersonic air down before it reached the engines. For flying at the edge of space. At 60,000 feet, Concorde flew where the sky fades from blue to black. Passengers could literally see the curvature of the Earth. While normal airliners cruised at 35,000 feet, Concorde soared nearly twice as high, above weather, turbulence, and even most other aircraft. At those altitudes, air density is thin, reducing drag, but also making control delicate. The plane's wings had to maintain perfect lift while managing intense heat and pressure differences. The cabin was pressurized to simulate an altitude of 6,000 feet, but outside, the air pressure was just a fraction of what we breathe. Every seal, every window, every panel had to be flawless. Inside, passengers experienced a surreal calm. While the outside air screamed past at 1,350 miles per hour, inside, the cabin felt like a luxury hotel, with champagne, fine dining, and even handwritten menus. The irony was stunning, a plane that could outrun a bullet, yet served caviar with silverware. 5. The mysterious moving center of gravity. Concorde wasn't just fast, it was balanced to perfection. At supersonic speeds, the aerodynamic center of pressure shifts backward. If nothing was done, the plane would pitch dangerously nose down. To solve this, engineers created an ingenious system. They moved the plane's fuel mid-flight. Yes, Concorde literally pumped fuel between different tanks to adjust its center of gravity. During takeoff, fuel was distributed evenly. But once the aircraft reached Mach 2, fuel was shifted toward the tail, keeping the plane aerodynamically stable without using control surfaces that could create drag. This fluid balancing act wasn't controlled manually, it was automated, monitored by a complex network of valves and sensors. In a way, Concorde didn't just fly, it danced, constantly rebalancing itself with precision worthy of a ballet. 6. The heat problem, when speed meets fire. Flying at twice the speed of sound has a side effect, frictional heating. The faster you go, the more the air rubs against the fuselage, and the hotter the surface becomes. At Mach 2, Concorde's nose reached 127 degrees Celsius, hot enough to bake bread. The aluminum skin expanded, forcing engineers to design joints that could flex without cracking. Passengers even noticed a small gap open between the wall and the window during flight, proof of the aircraft's living, breathing nature. 7. The art of supersonic navigation. Flying faster than sound means outrunning your own radio signals. Navigation had to be flawless, because any mistake at Mach 2 could mean missing a continent entirely. Concorde was equipped with one of the earliest inertial navigation systems, INS, a system that used gyroscopes and accelerometers to calculate position without relying on ground radar. Long before GPS, Concorde could find its location anywhere on Earth with astonishing precision. Pilots didn't just steer, they managed energy, altitude, and time with military-like discipline. Every flight was choreographed down to seconds, from when to ignite afterburners, to how long to climb, to when to transition into supersonic cruise. 8. The luxury of speed. While Concorde's technology was military-grade, its experience was pure luxury. The cabin seated only 92 to 100 passengers, arranged in a 2-by-2 layout. There was no first class, every seat was first class. The service matched the speed, lobster, champagne, fine wines, and sterling silver cutlery. Passengers included royalty, rock stars, and world leaders, from Princess Diana to Phil Collins, who once famously performed in London and Philadelphia on the same day, thanks to Concorde. Flying Concorde wasn't just travel, it was status, the ultimate symbol of prestige. 9. The sound barrier and the sonic boom. When Concorde broke the sound barrier, the world below heard it, literally. A thunderous sonic boom echoed across the sky, startling people and shattering windows. That boom came from shockwaves merging as the aircraft outran its own sound waves. While over oceans, it wasn't a problem, but over land, it was a deal-breaker. Many countries banned Concorde from flying supersonically over populated areas. This limited her routes mainly to transatlantic flights, London to New York, Paris to Washington. Despite the restriction, Concorde still redefined travel. Business meetings across continents suddenly became same-day events. But the sonic boom became a symbol of both her power and her downfall, a reminder that even marvels of engineering must obey the rules of nature and society. 10. The economics of speed. Despite her beauty, Concorde was never a profitable plane. Her engines devoured fuel, her maintenance costs were astronomical, and tickets cost more than most people's annual salary. Each flight burned nearly 25,000 liters of fuel per hour, and the titanium-like precision needed to maintain her meant mechanics had to inspect her after every trip. Airlines like British Airways and Air France continued flying her only because of prestige, not profit. Yet passengers kept coming. Flying Concorde wasn't about saving time, it was about living history, about being part of something the rest of the world could only dream of. In many ways, Concorde wasn't a commercial jet. She was a flying art piece, an experiment in what humanity could achieve when it stopped asking why and started asking why not. Why we haven't built another Concorde. So why, after all this brilliance, hasn't the world built another Concorde? The answer is a mix of economics, physics, and politics. Supersonic flight is brutally expensive. The fuel efficiency drops sharply, maintenance is constant, and environmental concerns, from sonic booms to emissions, make regulators nervous. In today's world of budget airlines and fuel crises, speed simply doesn't sell like it used to. The focus shifted from how fast to how cheap. And yet, deep down, humanity still longs for it. If you were amazed by the story of the Concorde, the jet that outran time, make sure to like, subscribe, and share this video. Because the sky might be quiet now, but dreams like this never truly land.